Hello and welcome to another tutorial. So this time we are going to be building on the previous tutorial where we were setting up a simple spaceship. So last time we got it going with visual effects, we got the movement, things like of that happening. So what I want to be focusing on this time is adding in some improvements, getting in some user interface in there so that we can see some key useful stats there, and also getting in some stuff where when we're applying thrust that we can have that induce a little bit of roll. And importantly, and this is something that's going to help with sort of stability for it, is being able to have a system there for correcting the roll. So an auto leveling system that we can have in there. So let's dive on in. So what I want to do to start off with is I want to get those bits happening in terms of the user interface and also in terms of the induced roll. So thrust-induced roll is essentially what we're setting up there. So let's work out with our user interface first what we want to actually sort of have. Now one of the things that I am going to do is I am going to create a prefabs folder because I want to set the spaceship up as a prefab just to make it a little bit easier. And then in terms of with the UI, so what I'm going to do is usually start off with just adding in a panel. So let's set this up as being instruments, we'll call this. So we'll call this Spaceship HUD. Now we're using the new event system, new input system. So by default, the input system, the event system, sorry, it adds in still actually uses the old standalone input module. So when you set up with the new input system and you've created the UI, you'll typically, if I didn't go and fix this up, I'd actually get some errors. So we want to just hit replace, and then that will be working correctly. So I've got my spaceship HUD, so I'm going to, as I would normally do with this, scale with screen size, usually go for 1920 by 1080 I find works well. And then our instruments, well this panel, I want this to be, if you think about sort of good locations for it, crashing into the ground is probably going to be one of the main things that would happen. So player's attention is going to be focused probably towards that lower half of the screen. So I think that's a good spot to be displaying information there. So that's all, and that's always something to keep in mind when you're laying out user interface and things like that. Where is the user's attention going to be focused? And you want to try and, in particular, if it's intense, high-speed things that are happening, make it that they don't have to necessarily look away or look far away, so that they're able to sort of stay focused on the key areas there. So about a height of 100 looks pretty good for that. So instrument-wise, I want to have a few different ones. So I want to have velocity, so it's speed. I want to have information there in terms of our location in the world, and also have information in terms of how far above the ground we are, because the ground could be variable height. So I want to have a few different things there in terms of information. So I'm going to set up a couple of panels. I like to always group stuff in panels. And under that, I will bring in just Text Mesh Pro, bring in the essential stuff there. So that's done. Now that text, I will keep that coloring because I'm actually going to change these so that they are making the background darker like that. So that's good. So I'm going to adjust the text so it's essentially fitting within the entire thing. We might make all of these can stay as left aligned, but I'll center it in them vertically. So I'm going to set up 3 panels, and what I'm going to do is set up a vertical layout group, horizontal layout group. They can expand height, expand the width, so that looks good. So, okay, good so far. So this panel is going to be the velocity display. Then I might have location display. And then on the right hand side, height above ground. So this will be velocity value, location value, and height value. So we can probably make all of these a bit larger. I want to make the stuff nice and easy to read. We could also have, indicators that are graphical would be great as well. Graphical is going to be really quick to parse, so that's stuff that could do as well. Could also use that for sort of providing warnings, things like that. So I'm going to set up a specific script for Spaceship HUD. So that way then that HUD can handle controlling all of the bits of information that we need. So we set this up, we'll set up our usual sort of binding of things. So bring in Text Mesh Pro, and we'll just set up so that we have Text Mesh Pro UGUI, so for the UI based ones. So we'll have our velocity value. We'll have another one for same sort of thing, location value, and then a height above ground. Now it's also going to need to know what spaceship it's talking to. So I'm going to just directly link that. So spaceship, linked spaceship. So that will be good. So how I generally structure things like this is one of those cases where, like I've done with other things, where I'll intentionally write code that won't work at first, that will actually provoke errors, so that I have to then go and fix those errors. So the velocity value, I want to set that text. So that's going to be equal to linked spaceship current velocity, and then I want to control the formatting of that. So I'm going to allow 1 decimal place, and that's meters per second. So none of these parameters exist yet, and that's okay. So we're going to have the linked transform here. For this, I want to have the transform.position.x. So I'm going to format this a little bit differently. So we're going to have x. We'll put a space there. I'm also going to make it that there's no decimals with this. And might want to make it so that it will put in an appropriate separator for the thousands. So by using the N0, that will put in the appropriate separator there, which will be good. We're going to have our Y value. And then we'll also have the Z value. So that's good. So I'm happy with that. That'll just make it easier for us to know sort of where we are. We could also do stuff where we're applying a little bit of padding there so that it's always taking up a consistent location. Either one works. And then so that's our location. And then height above ground. Can just call that height above ground. And that's going to be in meters. And this one, probably don't really need to go less than a meter, so I think again having it have the 1000 separator will be good. So okay, so far so good. What we can then do is populate these parameters here. So what I'm going to do is public float current velocity. And I'm going to populate this inside the fixed update. just because generally we only want to be accessing the velocity information inside the fixed update. But that'll just be the magnitude of that, so that's good. And then we also have this height above ground. So that's another one that what we're going to need to do is very similar setup. So we'll do that. Now we don't need to necessarily update that in fixed update. That's something that we could update just down here in our regular update method. We need to have a couple of things that we want to be doing there in terms of, because the only way we can really do that is a raycast. So above ground, check. So we're going to need a maximum range. So maximum range, so AGC, maximum range. I'm going to make this pretty large. So it'll kick in when we're at that sort of range. What I might also do is we'll end up looking at setting this to some invalid values potentially, so that we can tell if it's actually valid or not. So we'll have a maximum range. Might actually make that more like 2000. Then going to need a layer mask, AGC layer mask, and we'll default that to just everything, because then what we'll do in our update is we will do a physics raycast. Now we're going to need to look through the different versions. There's that many different versions, I never remember all of the ones that exist. But we want one of the ones where we can provide a layer mask and we've got like the hit info and max distance. So that looks like a good version. So that will be our transform.position. We're using world down because we want it to always be using the world down in this case. And then we need to, unfortunately it doesn't keep the display up. So then we'll have our hit info. So out, hit info, AGC maximum range, AGC layer mask, and query trigger interaction. We want to make sure it's specifically ignoring triggers. So if raycast hit info, check if it hit anything. Just going to bring these down so it's a bit easier to read. Check for the ground. So what I will do is height above ground. It's going to be -1, and then we will populate it here. So height above ground will then become hit info dot distance. Because then in our HUD, what we can do is we can check, well, if height above ground is greater than or equal to 0, we display it. Otherwise, we can just set it to 3 dashes meters. So essentially, we don't know the value. So that looks good. So we'll fix up stuff in terms of alignment here as well. So what I would usually do for things like if this is we orient them like that. So they're sort of spaced out nicely. So that looks pretty good. We might need to change the sizings of these a little bit, but that's something we'll be able to experiment with. So we need to link this to our particular spaceship. We need to link the different bits of UI here. And then the final thing I'm going to do is the ground here. I'm actually going to make it quite a bit larger, just so we've got a bit more space to be moving around in. So let's test this out. We just want to make sure we should see all of our parameters there updating. So that looks correct at the moment. Now we can see the height one, we need a little bit of an offset there, obviously. So it's still getting 1, and that's because we did not configure the layer mask. So what we're going to do, so easy to forget, we'll add the spaceship in, and then we will set, and what I will do is I'll actually open the prefab to do this, put everything into the spaceship layer, can save that, and then on the actual prefab, I will modify so the above the layer mask there, we get rid of all of these ones. We don't want it to collide with anything except for stuff that's in default and water. We also probably need a little bit of an offset there, so we'll set that up as well. So we'll have serialized field, float AGC, vertical offset, and it seemed to be we were offset by 1, so I might make that -1. So then when it does the actual position checking here, we'll add vector 3.up times by that vertical offset, because we expect it to be 0. That's what we're wanting to see for that. So because the center is right there at the very center, we needed to offset that. So that should now work a little better. We might need a bit more of an offset. That is now changing. We can see our position is changing, so that's good. As we move around, so it gives us a bit of a sense of our total speed, makes it a little bit easier if we need to sort of navigate back. So that's good with my terrible steering. So we need to offset the position a little bit more. Probably the easiest way for me to figure that out is if I take the ground and bring that up to what would be the center line. So it'd be there. So the ground is actually about 1.6. So that's what our vertical offset here becomes, minus 1.6. That should mean we start out at being 0 for the height there, which we do. And as soon as we're up a meter, yeah, so that's working. So that's good. So next thing I want to get going is this idea of having our thrust that we're applying, being able to allow that to induce roll. I am also just going to turn off the haptics for now, just because it gets very, very noisy. So having the induced roll. So the idea is going to be those horizontal thrusters, when we apply those, that will actually be able to induce roll. So we're going to have thrust-induced roll. So we need to control the intensity of this, and this will actually apply a torque. So we'll have serialized field, float, thrust, or max thrust-induced torque, because the more thrust we apply, the more of a torque it will apply. So thrust-induced torque, and I'm going to start that fairly conservative value of 5, so not having it be too large a value. So we've got our thrust vector here, so apply translational thrust. And then what I want to do is have the torque, which actually I'll do the torque down here. So apply thrust-induced torque. So what we can do is our induced roll. So roll is going to be essentially rotating left or right. So that's going to come from our thrusters along the x-axis. So the induced roll is going to be based off of that. Now I might also want to be able to have a little bit, as well as like that max, be able to adjust the curve of it. So I'm going to give us a animation curve of essentially the mapping from that thrust input to that maximum torque. So we could have that vary non-linearly. Animation curves are reasonably cheap. I tend to like to use them in cases like this if I want to fine-tune the feel for stuff. Because at very low thrust values, we might want to have it be essentially nothing. So, induced torque versus thrust curve. So then down here, we can evaluate that. Now, I don't want to have to configure that curve for the negative and positive values of thrust input. I want to just be able to configure it for whatever the input was. So only a 0 to 1 value. So throwing out the sign there. So what I can do is a mathf ABS. I give it the input, so input thrust.x. So I run the absolute value version, so the version that has the negative discarded, through the curve. But then I want to actually bring that negative back. So we can do that by multiplying by mathf sin, S-I-G-N, not S-I-N. Very, very easy to get it wrong. First time when I was prototyping this, I did get it wrong and was very confused why I was getting quite weird behavior. So S-I-G-N, something to watch for. Autocorrect can really mess you up in that case. So, okay, that gives us an induced roll that is going to be the correct sign based upon our input and is going to have run through that curve. Now, the other axis where we'll have stuff induced will be pitch. And pitch, so up or down, so that is going to be based upon thrust along the z-axis. So that's good. So now we can actually add that torque. So linked rigid body, add torque, and then we give it our induced pitch by the max thrust induced torque, 0 for essentially torque that would be causing a yaw, so a rotation around the y-axis, and then we have induced roll times by max thrust induced torque. So that's good. So now we can test that out. We'll need to set up that animation curve, but what we expect to see is then and I'll set up the animation curve on the prefab, just going to default to a standard S-curve sort of setup. So what I would expect to see then is as I apply thrust, so I'm going to hover up a bit, and then if I push forward, can see it's starting to pitch, and that will linger for a chunk. So it's going to be fairly slow because I've kept the value pretty low, but we can see there it is starting to, and if I move the other way, it's going to come back. If I go way overboard, it'll end up, we can get quite a tilt to a level that can actually be problematic. Now this is only applying a fairly small amount of tilt. We've got a fairly low rate that we're applying to this. We could ramp that up. So say I jump that up to something like 30. So quite a significant increase. That's going to impact on how much we need to manage this. As you can see, it's already sort of tilting. So that means we'll need to actively manage it a lot more. So that's something where adjusting that is going to massively change sort of the difficulty. As we can see, we get quite a lot of tilt there. And it requires quite a lot of management to control that. And to sort of balance that out. It makes it much more tricky to handle the flying of it. Still doable, but you also then need to really be balancing, and that's going to go probably pretty hilarious and bounce off the side. Or, yep, there we go. So it gets a little bit difficult to manage. I will drop that back down to 5 for now. But this is where having the ability to then have something be auto-leveling us, so applying a level of control to it. And that's essentially kind of what we're setting up, is a control system. Now, control systems are a huge area. Like, it's a huge field. There's a lot of stuff you can do in that. What I'm going to do is set up a fairly simple control system. So this is going to be taking into account how far off of vertical we are, and also be taking into account our current rotational speed. And we'll see what happens with the different ways we can tune this. As I said, there's a lot that you can do with control systems. They can get quite sophisticated, and you can get some really solid ones there for it. We're going to set up something that's reasonably basic, but enough that it will do the job for us. So, auto leveling. So with this, I'm going to make it that it's not on by default. Well, I'm going to make it that we can turn it off or on if we want to. So auto level enabled will be on by default, but we can turn it off. And that's something where with like this, you could have this as an upgrade that a user purchases for it. So, user does various things, they unlock the ability to then have this auto level system. You could have different levels of auto level system that work to different degrees is the other thing. So that's something we'll be able to control quite a bit. Now, these parameters I'm setting up here are ones where they're going to control essentially how strong, how intensely the system is working. So this is going to be normal scale factor. Actually, normal is not quite the right word. Up vector influence. I'm going to start it at 0 so we can see what happens as we change it to different values. So the up vector is actually a really handy thing for us for working with this, because the up vector, if we're perfectly vertical, is going to be 0, 1, 0. So 0 in X and Z, 1 in Y. As soon as we tilt either way, we will have non-zero X and Z components. So we can use them for working out how to steer back. So that up vector influence is going to control how strong that force steering it back is. Then we also want to be able to factor in the velocity, and this is the idea, this is going to act essentially as damping. Because if we just use something that's only looking at the up vector, it'll apply, the further away we are, a really large value, and then it will decrease as we get closer, which is good. But the problem there is it's going to, say, always be, say we're off and it needs to rotate us clockwise. It's going to always be applying a clockwise until we get close, and then it will flip over and it then has to apply anti-clockwise. So it will oscillate a lot. By taking into account the velocity that we're rotating, we can have something that's effectively a brake on it, so that the faster we're moving, the more that tries to rein it in. So that will it dampens down the oscillations a bunch, which is going to be helpful. So auto level, angular velocity influence, and again, defaulting that to 0. So I'm going to then set this up. This will be done down here. So F auto level enabled. So first thing I want to work out is my leveling vector. So essentially, what direction does the up vector need to move to go back to center? So going to vector 3, and this is our leveling vector, and that's going to be new vector 3, and it will be minus of transform.x, because we want to move that x back to 0, nothing in y, and again minus transform.z. So that looks good. Then we need to calculate the auto level components on the roll axis and on the pitch axis. So how this ends up looking, I think that actually should be that. This will be auto level for the roll component. So we take our leveling vector, we take the x value, and we multiply that by our up vector influence. Oops, transform.up. So we multiply it by that, then we add to it our angular velocity, and we want the angular velocity. In this case, because it's the rotation, we want z, not x, and auto level angular velocity influence, because the rotation about z is that's actually going to be the correct one in this case. So that will work for the roll component. Then the pitch one is going to be quite similar. So we have pitch, and that x's become z's, and z's become x's. So that looks good. And then what we would do is linked rigid body, add torque, and we have our auto level pitch component, nothing again in yaw, and auto level roll component. Now, in terms of how I came up with this is something where my background's in aircraft engineering, avionics side of things. They're working with control systems, so I'm very familiar with the control system side of things and the sort of formula, the structure for a basic control system. So that's how I knew how to work this out. I was based upon that. And there was a little bit of trial and error of using different components to see what was going to work most effectively. So there's a bit of trial and error involved in this. We'll also likely find, and this is something we will do a bit of testing, because we'll end up finding that we need to usually chuck in a negative sign for some of this stuff, but that's okay. First thing I want to do though is be able to test this. So what I'm going to do is I'm going to freeze the position, and I'm going to move this up 50. Because what I want to do is I'm going to set this so we have auto leveling happening, and I'm going to make it that we just have an influence on that. And we're going to test each one. So we'll test it. Okay, we're pitched forward. What we want to see is that pitches and returns back to 0 when we enable auto level. So in C, that is decreasing, but we'll expect it to overshoot. That's what we know is going to happen because we don't have that velocity component. Let's test pitch the other way. So we want to test positives, negatives, make sure they work, and we'll test pitch and roll in isolation. So we turn on auto leveling. It's returning back to level, so that's good. So I'm going to put auto level on by default. Then for the roll correction, let's test. We want to see, and that's rotating the wrong way. So we saw that wasn't correcting back the way that we expect, and that's fine, that's to be expected. So what we can do is, we knew we would likely end up needing to negate one of the ones, so we'll update that. So the roll component should be returning then back. So we'll just test with that. That's what we want to see. So that's leveling back, so that's good. We'll test with it set to -30. And again, we should see it decrease, which it does. So good so far. Then let's test the combination, because that's something that is, we want to make sure there's not an issue there. So we should expect both of those to start reducing to 0, which they are, which is good. So now we can start to test making sure that this has got some braking on it. So something that's restraining in, because what we'll see And if I actually bump this up to like 200, we'll see it a lot clearer. It'll actually oscillate. So it may eventually dampen down, but because it's applying a pretty high angular force, it's going, so it gets to minus 25, and then it's going to go, probably it'll be 20 or so. So yep, so it's decreasing. The oscillations are decreasing, but we want to have them decrease faster. So what I'm going to do, and a lot of this stuff is a level of trial and error. So if I chuck in 200, so I usually would start probably either around about the same as or more. So if I chuck in 2000, we can see that, at least on the efforts on the X there, that actually makes it get worse. Let's check if we see the same thing happen with Z. So we're going to run that. So with this one, levels, overshoots a little bit. We don't have the velocity compensation in there, so we'll chuck that in now. Well, with this, it levels off super smoothly. There's not the oscillation happening, so we're good for on the roll side there, but the pitch side, it's definitely running into issues. And as soon as it starts to induce a little bit of pitch, it goes way, 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 way not good. So what we actually need to do, and this is not unusual, where with that, we need to actually be using the negative of the angular velocity. And just for that. So it's often not unusual that you'll have slight differences between the two there for pitch and roll. So we'll do that, and let's test and see how that behaves. So you can see it goes back a bit slower because the velocity is actually working counter to it. So that's going to come in a lot closer. It should be pretty darn stable because you can see it's sort of slowing down. That influence is lessening. It'll probably oscillate potentially still a little bit, but it should be actively dampening down those oscillations. We can see it's not overshooting, which is good. So let's stress test it a bit more, and we'll make it trying to return from that. So you can see both are decreasing. It's coming back at a decent sort of rate, which is good. We could also have stuff there where it looks at how far off it is, and it is changing those parameters, those influence ones, based upon how far away it is. But we can see it's managing to bring both of those back. We can experiment with adjusting the different values here, the relative ratios of them. So if we went for like, having it be 1000, that's going to make it a bit more responsive. So that means then we can now test with this enabled. So we'll turn off freezing of position, we'll return our rotation back, and we'll go back to our position from before. So then with auto leveling enabled, we'll still get some rotation being induced, but it's going to pretty rapidly return back to 0. So it's going to make it a lot easier for us positioning and moving around and things like that. And we can also test our ground radar sort of set up here, where this should, when we go over this, should drop a lot more. So because the raycast will be able to be hitting then the ground. So you can see it goes to 5 meters. So this will also make landing a lot easier as well, because it's going to be harder for us to end up rotated. And even if I bump up the thrust-induced force a bit, then I should still have a lot more control, because it is going to be able to tilt, but I've got stuff actively bringing it back. And this would be something where what we could do is we could actually allow that to be turned off. So we could have it that auto level, like I said, is an upgrade or is something that a user can actively control. Because it's actually now quite difficult to get much of a rotation. and it'll very quickly return back to a level rotation with those values that we've currently got. So it's going to mean things like landing, stuff like that is a lot easier because we don't have those rotations happening. And I'm going to just, let's really stress test it. Let's double it so it can induce quite a lot of rotation. And with that, so we do rotate a bunch, but quickly comes back to normal. So even with pretty hefty amounts of thrust, we can go and it returns back. So our roll compensation is pretty good. Very rapidly starts to return back to a level value. And that's exactly what we want. And now that we've got those location bits of information in there, we can also get a bit of a better sense of where we are in the world. So that's making it a lot easier to know sort of where we are, which is good. Because those correspond just to the world location. So then can very, very easily just come in and we can see our speed. So we know, and that's something where having that speed display makes it a little bit easier for getting a sense of, okay, being able to land gently. So if you had stuff like damage, fall effects, things like that. So that's good, we've got those up and running. I'm going to actually set the default thrust-induced torque up to 30. And then I'm going to update the prefab. Now I'm going to be a little careful with updating this because I have found in the past doing an update all in cases like of this where it's got ProBuilder components, I do run into issues. So I'm going to just update stuff on the specific scripts. So I'm going to apply those. Rigid body, I don't think actually has any changes. No. So that same everything there, those are all exactly the same. So I'm going to leave that. I think what it is it's because it's got some initial sort of info in there, or maybe because there was a few changes. I might actually just do a revert on that. Interior camera, that has just a marker location in that for us, so that I'm going to make sure that's in the prefab. But that's our updated setup. So we've got our displays, things like that going. So that's working quite nicely. We might just put in a little bit of text here. So speed, position, altitude, we just want to check and make sure those still fit. Always good to just double check that everything still fits. We might need to tweak sizes a little bit. That should still fit. Yep, so that's still good. So we've got all of that up and running, and I'll put the HUD as a prefab as well, because that's a useful thing to have prefabbed. So we've got now roll control and inducement of roll in there. We've got some UI going. There's going to be further updates that I want to make to this. There's a bunch of extra things that I'd like to be adding in. So I want to add in some things like auto landing, being able to enter and exit the spaceship, stuff like that. So there'll be a bunch more controls, things like that I'm adding into this in future videos coming along. Thanks folks, I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, really appreciate it. If you got any questions, chuck in a comment below. If there's other things you'd like to be sort of seeing, if you want to chuck in any suggestions, chuck those in a comment as well. If you're looking for the code for the project, that code is available up on GitHub, and I've put the link to that in the description below as well. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description as well. But until next time, bye.